Moving on to absolute value inequalities, we're sort of going to build on the past two examples where we solved the regular inequality and solved the compound inequality, and put those two ideas to work to solve this absolute value inequality. So just like a regular inequality, we can start off by sort of treating these almost as if they were parentheses at first, and subtracting 2 from both sides. So we have 3 times x minus 1. We'll subtract the 2 from this side, subtract the 2 from the 8, which will give us 6. So we have 3 times the absolute value of x minus 1 is less than 6. From here we can divide both sides by 3 to leave the absolute value expression by itself, and we'll have absolute value of x minus 1 is less than 2. From here, from what we know about absolute value, we can actually split this into a compound inequality, right? So absolute value, meaning the distance from 0, is going to allow us to say that if x minus 1 is less than 2, right, the absolute value of x minus 1 is less than 2, that means its distance from 0 has to be less than 2, which means it has to be less than 2, or it has to be greater than negative 2, right? Because if we exceed 2, say we went to 3, then that's going to be greater than 2 from 0, and if we went to negative 3, that's also going to be greater than 2 from 0. So we'll split this up to say, okay, this will be x minus 1 has to be greater than negative 2, and x minus 1 has to be less than 2. And now you may be wondering, why is this and why not or? And that's a good question. It's coming from this less than symbol, right? Because this has to be both less than 2 and greater than negative 2. I mean, that's sort of a terrible explanation, but even as I say it, like the words come out, kind of, to be within 2 units from 0, you have to be both less than positive 2 and greater than negative 2, so that's where the and comes from. But it's going to be the less than symbol, in this case, that gives us that hint that we're going to use and it would be the opposite, say, if this was the absolute value of x minus 1 greater than 2, right? Then that would either be greater than positive 2 or less than negative 2, one or the other. But the less than symbol here is what's going to give us the clue to use and. But then from here we can just solve this very much like the compound inequality we've done previously. So we can say, okay, we'll add 1 to both sides over here. So this is going to be x is greater than negative 1. And we can look over here and say, okay, we'll add 1 to both sides, and this will be x is less than 3. Now we can write that out in interval notation. X greater than negative 1 is going to be negative 1 comma infinity, right, going from our lower bound to our upper bound, which in this case there is none, so we'll put infinity. And, which we know we can replace with the intersection symbol, right? And for intersection, or for union. And x less than 3 will be negative infinity to 3. And we can leave it like this if we want, but we actually can simplify this further to say what are the values that are both greater than negative 1 and less than negative 3, or excuse me, less than positive 3. They're going to be all of the values from negative 1 to 3. And we can write it just like that.